All right, so we've already talked about polar coordinates. So now we're going to look at polar equations and Cartesian equations. So we've got it. So we did where we have polar to Cartesian. So we've got points like this. Let's say it'll be x equals your r times your cosine of theta. So if we know maybe our r value, our radius, and if we know our theta value, then we can find our x, or we'll have y equals r times sine of theta. Okay, so either of those, if you already know your polar points, so like if you know your r and your theta, okay, then you can find your x and your y. Right? So same thing, if we have an equation that's set up in r and thetas, then we could change it to Cartesian and vice versa. So we can change Cartesian to polar. So Cartesian, that means that we know maybe our x and our y. So we have something like this: x squared plus y squared is equal to an r squared. And then our other one is that tangent of theta is equal to y over x. Right? Because we can find our theta by saying inverse tangent of that y over x. Okay? So let's try to convert each rectangular equation into a polar equation. So we're just going to use the same thing with our points that we have here. So I want to convert each rectangular equation to a polar equation. So I've got x plus y is equal to 5. All right. So how in the world can I change x and I can change y where maybe it looks something like a polar? So I want it to be in terms of r and theta. Okay. All right. Well, up here I have x is going to be equal to r cosine of theta. So can I plug that in right there? So can I say r times cosine of theta? And then y up there is equal to r sine of theta. And this would be equal to 5. Okay. So to put this into a polar equation, we can factor out the r. So we can factor out the r and we'll have cosine of theta plus sine of theta is going to be equal to 5. So then I can divide both sides by cosine of theta. So this is going to be r is going to be equal to 5 over cosine of theta plus sine of theta. Okay. All right, so what about b? So try b for a second. I want to change this rectangular, so Cartesian, so to a polar. Okay, well, I've got some squares, so maybe put it in terms of x squared plus y squared is going to be equal to an r squared. But to be able to do that, I need to multiply out x minus 1, all of that squared. All right, so let's do that first. So that'll be what? X squared minus a 2x plus a 1. Okay. And now do I see something that could help me out with my x squared plus y squared? So do I see maybe an x squared plus a y squared here? On here? So I can, let's see. So if I rearrange this, it'll be x squared plus y squared minus a 2x. If you move your 1 over, then that just is going to be equal to 0. Okay. All right. Okay. So I've got x squared plus y squared, so that's the same thing as having an r squared. And then what is x going to be equal to? So x is equal to r times cosine of theta. Okay. I will factor out an r here. So I'll factor out an r, and I'll have r minus 2 cosine of theta. It's going to be equal to 0. I'll set r equal to 0, and then I'll have r minus 2 cosine of theta is equal to 0. So I'll have r is going to be equal to 2 cosine of theta. All right, so already right here, Cartesian, this is a circle, right? So my center is at 1, 0, and my radius is going to be at a 1. So we know that r cannot be equal to that 0 right there. So we're going to throw that part of the equation away. Okay, so my polar equation that's going to be equivalent to that same thing is going to be r is going to be equal to 2 cosine of theta. Okay. Alrighty. So let's go down here and look at convert each polar equation to a rectangular equation. Okay, so let's go back up and remember our terms. So I have a polar that is r equals a 5. So it's got to be a circle, right? So if you think about it, this is a circle with a radius of a 5, right? So my center is going to be at 0, 0. But let's try to turn this into a rectangular equation. So what happens to have an r? I want to turn it, I'm going to erase these little highlights here. So, oops. To have it in Cartesian points, okay, then I need maybe an r squared, right? So if I had an r squared, then I could turn it into that x squared plus y squared, right? So these 1, 2, 3, 4 equations are going to be super helpful for you converting back and forth. Okay. How do I get an r squared? What would I do to both sides to make it be an r squared? Okay, so we can square both sides. All right, so if I square both sides, that'll be an r squared. It's going to be equal to a 5 squared. R squared is the same thing as x squared plus y squared. And then 5 squared is a 25. So that is your the same thing for your rectangular equation. Sorry. Do I hear my dog? My dog is doing something over there. Okay. All right, so let's look at B. So B, I've got theta is going to be equal to pi over 4. So on the polar, that is going to be pi over 4. So pi over 4 is like this. It's a straight line. Yes. So here is pi over 4. And we don't have a radius. We just have our pi over 4. Okay. So is there something that we could do to both sides to get it in terms of y over x? Okay. So tangent of theta is the same thing as y over x, right? So if I took the tangent of both sides, so if I take tangent of both sides, then I'll have the x and y ratio. Okay, so we'll have tangent of theta is going to be equal to tangent of pi over 4. So tangent of theta is y over x. Tangent of pi over 4 is square root of 2 over a 2. So now if you put it as a straight line, multiply both sides by a x, right? So you're going to end up with y equals square root of 2 over 2 times x. Good? All right, y'all try the next one for me. Okay, so I've got r equals 3 times cosecant of theta. Well, what is cosecant of theta? So cosecant of theta is the same thing as 1 over sine. Yep. So let's remember y is going to be equal to r times sine of theta. So what if I multiply both sides by sine? So if I multiply both sides by sine, then can I get it in terms of y? I could, right? So this will be r times sine of theta. It's going to be equal to a 3. Well, r times sine of theta is the same thing as y, so this will be y equals a 3. That's it. So this one is a straight line as well. So this, even though I'm not real 100% sure what that means in polar form, it's y equals 3. So it's going to be a line that looks like this. Okay. All right, what about D? So D is a little different than what we just did. So you would think that you want it in terms of r times cosine of theta. So to get at r times cosine of theta, I need an r over here, right? If I divide both sides by cosine of theta, is that going to help me out any? So I'll have r over cosine, but there's nothing that tells me that r over cosine is something, is x or y, right? That's not going to help me. So we don't want to do that. So that's not going to be helpful to us. So how could I get an r right here? What would I do to both sides? You could multiply both sides by r. Okay, so if you multiply both sides by r, you'll get r times r, and then negative 6 times r times cosine of theta. So what is r squared? So this is r squared, sorry, negative 6 times r times cosine. Well, what is r squared? R squared is the same thing as x squared times y squared, or x squared plus a y squared, I'm sorry. So x squared plus y squared is an r squared, so I could change that. So this will be x squared plus a y squared. And then r times cosine is just an x, so this will be a negative 6x. So this is going to be a circle, right? So this is a circle. But I would need to complete the square. Okay, do you remember how to do that? So to complete the square, so you'll move the 6x to the other side, so it'll be x squared plus a 6x. And you're only going to need to complete the square for the x value. Okay, so what's half of 6? So half of 6 is 3. And 3 squared is a 9. So remember, you add that to both sides. So you add 9 to both sides here. And then you'll factor this one. So this will be x plus a 3. All of that squared plus a y squared is going to be equal to a 9. So that means that this is a circle. So these two, this polar equation and this Cartesian equation are congruent to each other. So these represent the same thing, okay? Those are the same. Okay? All right, so I want you now to do the card sort. So I'll put a link up for you for the card sort, and this is where you will write your information for the card sort, like trying to figure out what this graph is and what it represents. So I want to see this as well. So please, if you can, upload that for me in Canvas. So I want to see this part. And then I'll post the rest of the video for this, like the answers to it, on Monday. Okay. All right. Y'all have a good day.